Hello everyone, this is Nitin Sharma. In today's presentation, I will be discussing upon a very interesting and new network function in 5G architecture, that is NRF, Network Repository Function. So recently I was going through the 5G specifications and I found that how this function is contributing in 5G procedures, and we'll be looking at one procedure as an example in which you will see the role of NRF in setting up that procedure. So before that, in next slide we will be discussing a brief summary of 5G architecture, that is service based architecture, and after that we'll proceed with our main objective, that is role of NRF in 5G. So let's see what's up in next slide about 5G architecture, service-based architecture. So friends, we have two different notations or representations of 5G architecture. One is the reference point and second one is the service-based architecture. So in reference point, the way of representing the interfaces is like this, as N1 and N2, N with the numeral notation. While in SBA, the interfaces are represented in this format, N with the name of subsystem, N and SSF. So this is the interface of this function. This is the very basic difference between the two way of representation of 5G architecture. Another important feature of 5G SBA architecture is the base protocol. So first time in 5G we are going to use HTTPS as the base protocol over which all the entities of SBA architecture will talk to each other. So as we are aware that HTTP messages like put, get and post, these messages will be used by these entities in putting some query to the server and getting response. Another important parameter is service consumer and service producer. So the server who is giving its services is the service producer, and the client who is taking services from the server is service consumer. We will see this in the coming slides, how service consumer and service producers will be exchanging messages between each other. Now let's have a quick introduction of all the entities in this architecture. So let's start from this ngRAN. ngRAN is basically the E node B of EPC that we can correlate with. AMF is like the MME of EPC, and AUSF is like the HSS of EPC. PCF is the PCRF of EPC. So when we come to the SMF and UPF, basically this is the P gateway from EPC that is divided into two parts. This part will take care of the control and signaling part, and the lower one, that is the UPF, will take care of only the user plane part of P gateway. So basically in EPC it was the P gateway, and in 5G it is divided into two parts, SMF and UPF, for do better layering and better scaling. They have different advantages. We'll not go into too much depth of this separation. So this is the P gateway. Now the UDM. UDM is basically the repository, or you can say the database, to keep all the subscribers data. So if any function or any element wants to access the wants to fetch the subscriber data, it will query the UDM, and UDM will give all the data to that particular function. Now at last we have these three elements or functions that are very new and interesting in 5G architecture. First is the NSSF, second is NEF, and third is NRF. So NSSF basically is the slice selection function. So the main functionality of this function is to help in giving slice of network according to the user requirement. Let's say if one user needs high throughput, it will give the slice of network, or maybe the combination of network with high capacity for throughput. Maybe second user needs high reliability and low latency, so it will give that chunk of network, maybe SMF, UPF, AMF, according to its need, to give high reliability and low latency. So as per 3GPP specifications, currently we have three types of slice selection identity. One is the URLLS, ultra reliable low latency services, that is for maybe medical, doing remote operations or driverless driving. Second is the broadband, that is the normal broadband, that is for high throughput. And third one is for the massive IoT, MIoT, that is for IoT services. So this is about NSSF working. Next is NEF, network exposure function. This function is basically to expose our 5G network to the third-party applications over RESTful APIs. So maybe like Facebook or Google or some other application wants to access our network for doing some customization for any particular subscriber, or maybe they want to use our database to customize some solution, or according to their need. They have n number of needs, so accordingly they will put request to NEF. NEF will fetch the data and respond them with the data they need. So that is the function of NEF. So NEF is basically the interface over RESTful APIs towards the third-party servers. Next is the NRF. NRF is network repository function. So this is the focus of this presentation. We will see, we will dig deeper in NRF functionality and role in the coming slides. So let's see what are the roles of NRF in the next slide. So friends, in 5G core, all the elements or the network functions are virtual. They are running over cloud architecture. So it may be possible that at any particular point of time that virtual function may come down, or the virtual machine over which they are running may come down. So what will happen to the services that they are offering? So there is need of someone who can keep track of, who can keep record of all the services of those network functions. So here comes the role of network repository function. So it is basically keeping the record of services that all the network functions are offering. In other words, we can say that all the service producers are nothing but the network functions like AMF, SMF. So they have to register their services in the NRF database, so that if some service consumer comes, he will that service consumer will query the NRF and select the service producers according to their need. In this slide we can see four different types of messages that NRF supports. First is service registration. This procedure is basically used by the service producers to register themselves with the NRF. So if there is new network function coming up in the network, it has to register itself in the NRF using this procedure, service registration. So in that procedure, or in that request, it will share some information about itself. As you can see in the box, in the HTTP body, it will contain the type of NF it is. Let's say it is SMF, so it will share the information that I am SMF. Then it will share the slice identifiers, to which slice selection it belongs to, the name of PLMN, the IP address or FQDN of itself, and supported services, what kind of services it supports, like SMF support, NF, SMF, management, session creation basically. So these things it will share in the network service registration request to the NRF. Along with that, it will, and all these information will be sent in HTTP put request. As you can see, it can send the address of itself in the database of NRF. It represents itself in the NRF database. So first part, this let me highlight. This thing represents the host, and this is the version of HTTPS v1 NF registry resource. This could be the information about the directory where it wants the information to be stored, and this is the address of itself, SMF address. SMF8 is sending this request, or you can say SMF8 is getting its services registered in the NRF. So this is the uh, message format or HTTP format in which they share all the information to the NRF in service registration. Similarly, there is second procedure, that is service discovery. Service discovery is basically done by the service consumers. Let's say AMF. AMF will do the service discovery procedure with the NRF to find the address of SMF. So consumers, service consumers will do service discovery procedure to find the service consumer. Oh, sorry, service producer. I'm sorry. Service consumer will do service discovery procedure to find the relevant service producer. In the third procedure, it's service update. This is done basically by the service producers who are already registered in the NRF to update some changes, to update the NRF about the changes in their profile. Let's say IP is getting changed, FQDN is changing, or supported services. Those parameters that the service producer shared in service registration request earlier, if any of them is getting changed, then it will update the NRF using this procedure, service update procedure. And last one is the service deregistration procedure. This is done by the service producers if they are getting down. As I explained earlier, that if some VM is getting down, it has to do service deregistration from the NRF. So in next slide, we'll see how these messages will flow between service producer, service consumer, and NRF. So friends, before I jump on to this procedure, I would like to explain you the difference between the put request of HTTPS and post request of HTTPS. So guys, the basic difference between though both the requests are to create an entry in the database by using HTTPS, but we still have some difference between these two. Put request is done when we know the address of the resource, or we are sending the address in the request itself for the resource to be saved in the database. So if we know the address, or if we are sending the address where we want our resource to be stored in the database, then we send the put request. And when we don't know the address, the exact address of resource, then we send the post request. And we'll leave the rest work to the up to the server, that it's server job where to keep that. It will search all the entries and do the required entry according to the request. So the basic difference is, I have written here also, address of resource is known, then we'll do the put request. Address of resource is not known, we'll do the. So in this example, I have taken session creation or session establishment as an example. uh, when we get the session establishment request at AMF will do the required authorization and authentication. After that, AMF needs to find out the SMF according to its requirement. Let's say AMF want slice selection. AMF wants one SMF with X slice selection and Y PLMN. This is the requirement of AMF. So AMF will do the query in NRF using the procedure service discovery. So NRF need to have all the uh, record of all the network functions before the service discovery. So as explained earlier in previous slides, SMF, or in this case SMF, but all the network functions have to register themselves first with in the NRF. So here SMF, in this example, SMF is registering its services in the NRF by using HTTP put request. So why HTTP put request is used? Because here SMF is telling the NRF the address where it wants itself to be stored, or where it wants its profile to be stored. So in this example, SMF is sending HTTP put request with all the parameters I like explained in previous slide, PLMN, slice selection, and its address, IP address or FQDN, and services it supports. Those things in the HTTP put request. And NRF will respond back with the 201 created request. That means that all your services are registered with me. So here you can also see that SMF here is consumer, because it is using NRF services, NRF service in this procedure, because NRF is providing the repository service to SMF. So SMF is the consumer and NRF is the producer. So I hope this is very clear with you. After service registration, when session establishment happens, so AMF will send the HTTP post request. Why post request? As I told you earlier, because AMF doesn't know that which SMF it has to address. So it will send a generic query to NRF in the form of HTTP post request, and NRF will do the search in its database that according to the requirements of AMF, and respond back with the list of SMF that matches the criteria of AMF. So HTTP post request goes to NRF, NRF responds back with list of SMF with 200 OK. So here AMF is the consumer and NRF again is the producer, because AMF is again taking the help or taking the service of NRF to find out SMF. So now AMF has the list of SMF, so it's AMF decision to which SMF it will send the request. Maybe it is load shared, or maybe it is active standby, or maybe it depends on the configuration AMF how it selects the SMF. So now session establishment message goes. So now AMF will send the HTTP post request to SMF for the creation of session, and SMF will respond back with 201 created when the session is created successfully in SMF. So in this request, AMF is the consumer because it is using session creation service of SMF, and SMF is the producer of this procedure, of this message. So friends, in this final slide, let's have a quick recap of what we understood in the last few slides. So initially we understood the difference between SBA, that is service-based architecture, and reference point architecture. Then how HTTPS is the base protocol of SBA, and how they are communicating with each other. Then we had the brief intro of all the 5G network functions one by one. The concept of service consumer and service producer in SBA, role of NRF in 5G, how it is keeping the registry of all the network functions providing services, and the different procedures it support: network service registration, service deregistration, service discovery, service update, like that. Then we also understood the difference between put request and post request of HTTP, and how important it is in the service, in the session establishment procedure, and maybe other procedures also. Then we had one example of session establishment, and we understood the role and importance of NRF in that procedure. So this is all, friends, about NRF and its role in 5G. Maybe I will make a few more slides. I will keep on making, I'm sorry, I will keep on making slides as soon as I will understand the new topics in 3GPP specs of 5G. Thank you for listening.